Hello and welcome, this is Victor. In this video, I am going to show you 5 common mistakes students make when they write their C++ programs. All of these mistakes are actually very subtle and are typically not caught by the compiler. So that means if you make these mistakes the compiler won't be able to tell you, and you will see the code running, and sometimes it will manifest itself, sometimes you won't catch it. I'm making this video so that you are aware of these mistakes, and if sometimes your program doesn't behave as expected, you can check for those common mistakes and see if you actually make them and correct them potentially. So the first common mistake I want to show you is the placement of the increment and decrement operator. So in a lot of programming languages, you might have come across with something like this plus plus or minus minus. What it means is that when you have an integer variable and you want to add 1 to the value, or you want to subtract 1 from that value, you can actually have several ways to do that. Let's say if I have an integer value called I set it to 0. Then if I want to add 1 to it, so that I want my integer I to store a value 1, then I can do the following. I can say, I equals to I plus 1, right? So I add 1 to it, so then now I becomes 1. Another way to do that is there's a shortcut for adding numbers, so you can use this one. So essentially you are doing the exact same thing. Sorry, not this one, but plus this one. So what you're doing is this is equivalent to saying I equals to I plus 1. The third way to do that is you can do this following. What this actually does is this is almost exactly the same as this one. You are this is 1. And you are going to add 1 to this variable. All right. Now we are going to remove these guys, and we are going to focus on this plus plus. So now we know that it is adding 1 to the variable. So to see what's happening, we can print the content out. So I can say I is something. So this something is value, and I'm going to add a new line over here to make it look a little bit prettier. And after I perform this plus plus, I'm going to do exactly the same thing. Now is now, and then it is equals to I dl. Right. So let's take a look at how it works. So we run the code, and then you can see that I starts with 0, which is what we expect, and then we increment it by 1. Right. Now so far so good. Now the interesting thing is that you can also do the following like this. You can put this plus plus operator in front of I, and if we run the code again, you will notice that it is showing us the exact same thing. So it seems that these, the placement of this plus plus doesn't really matter, and the truth is it actually does matter. And to show that, I'm going to remove this line, and I'm going to combine that statement with here. So what I'm going to do is I'm going to put this plus plus operator at the end of I, and let's take a look at the result. So here you can see that the value of I actually doesn't change. It stays at 0, right? Now I'm going to show you if I put this at the front, what happens. You will see that the value actually becomes 1. So why is that the case? So the reason that that happens like that is because this placement of the increment operator actually will tell the code to first add 1 to it before the whole thing is being the value of I is being evaluated. So what it means is that if I'm putting the plus plus at the front, this will first being evaluated. So I is going to increment by 1. So it means it becomes 1. And then that's why once you print the content of I, the variable I, you will see the value 1 here. Whereas if I put the plus plus at the end, what it means is that I'm going to first take a look at the content of the variable I and print the result. Once it's being done, then I'm going to add the 1 to my variable when all of this statement is being executed. So that's why when I run this code, when I put the plus plus at the end, you'll see that the value is going to first show up as 0, and then But if I actually print it out again, let's say I print this I again. So I haven't changed the I at all here in this line. I'm simply just printing it again. Now let's take a look. Now you will see that now it is having the, let's just add a space over here. You will see that now I have the I, the value stored in I now becomes 1. That's because after this statement on line 11 is being executed, then the content of I is going to be incremented, and that's why you will see the value 1 over here. All right, so the second common mistake that I want to show you in this video is how C++ performs divisions with numbers. Over here, we start with an empty main method, and we are going to first create a few variables. So let's say I have a variable called I, and I set it to 5. Okay, and I have another variable called J, and I set it to 2. All right. Now let's say I'm just going to use this program to figure out what is the answer of 5 divided by 2, and I'm going to use the variables I and J. So I can simply just out the result. So I can say I divided by J, which we know is 2, is something something, and this something I'm going to use the program to calculate it. So it's I divided by J. All right, and just add a new line over here. Okay, so from our mathematics, we know that 5 divided by 2 is going to be 2.5, right? So we would expect this to be calculated by the program as well. So let's take a look at the result. So you will see that instead of showing us 2.5, it's actually showing us just 2. And you might actually have already guessed this is actually the quotient or the integer part of the quotient, right? So the remainder is not there. Now this is exactly what we would expect, not what we expect to happen, but this is exactly how C++ calculates defined integer numbers. In C++, in a few more languages, when you perform a division between two integers, in this case I and J, if both of them are integers, then the division, the answer of the division is going to be an integer as well. So it's going to truncate whatever the decimal place that you might get from the division. It doesn't perform any round up. You can see it as round down, but basically what it does is simply just truncate the decimal place if there is a decimal place after the division. So that's why you will only see 2 over here. Now you might ask, so what if I really want to know the actual number? I expect it to be 2.5. So the way to do that is you have to force at least one of your operands in the division to be a non-integer. The quickest way in C++ to do that is by doing this thing called casting. So you can cast it into a double variable, which means that you are actually working kind of like in the decimal places domain, right? So what you're doing here is actually, what I'm doing here is I'm going to make this become a double variable, which includes decimal places. So if I've done that, that means that I have at least one operand being a non-integer. Right, so let's take a look at what happens if we do that. Now you can see that now it correctly performs the division and gives us the decimal place as well. So we can see that it's a 2.5. Now you can do several ways to do that. You can say, you know what, for whatever reason, I don't want to change it to double. Can I do this like this? Right. Can I just make J as double instead of I? The answer is yes, you can still do that. As long as there's one being turned into a double variable or float, then the division is going to keep the decimal place, and that's how you can see this here. Right. So that's how you can fix this, and this is what happens if you do not have this and you only are performing integer division. The third common mistake that I want to show you is like this. Let's say I start with an integer number, so like this. right? And then I perform a bunch of random stuff. So I'm going to say random stuff, right? Random stuff. And then I do more random stuff. Okay. So at some point, I decided that, you know what, I want to add 1 to the variable I. Maybe there's a reason, there's a condition, I want to do that. So I'm going to say I equals to I plus 1. All right. So far, so good. And I'm going to either examine the value or use this value to as a comparison to do something else. But for simplicity's sake, I'm going to just output the value of I onto my console screen. So I'm going to say I is, and then I'm going to retrieve the value stored in the variable I, and I'm going to add end of line here. Right. So let's take a look at what happens. Right. So you can see that instead of like it gives me a very random number. It's like 32727. If I run this code again, you will see that it changes into something else, right? If I run this yet again, you will see that it also changes quite a bit. So why is that the case? So the reason or the mistake that I'm making here is that I haven't initialized the variable I. So what it means is that when you declare a variable, behind the scene, the program is going to request a memory space in the computer. And what it simply does is just say, okay, I want a space to store an integer. Fine. So computer said, okay, well, here's the space. But the computer doesn't actually prepare the space or wipe the space for you. So whatever is originally stored in that memory space, maybe some bits are being turned into 1, some bits are turned into 0, they will still be like that. The program doesn't automatically receive the memory space wiped clean. So what it means is that when you simply just use an uninitialized variable, that is, you did not set it to any initial value, then any following or subsequent operations is going to just add things or subtract things from that value. That is like a residual value from previous other programs. So that's why you will see some random things happening over here. So to solve this, the rule of thumb is you always initialize variables when you declare them. So there are several default values that you typically want to use. When it is a number, typically you want to initialize them with the value 0. Right? And if it is a pointer, then you typically want to initialize that with a null value. In this case, since it is a number integer, I'm going to initialize it with the value 0. So let's run the code again. Now, as you can see that now I is behaving the way we expect. That is, it is just adding 1 to an original value. Of course, in your case, if you are expecting a different default value, like say 10, you start from 10, you will set this as 10. But typically, we will initialize a variable without any, if there's no assumption behind, we'll typically initialize that with 0. So I will not come up with like random numbers. So if I run it again, you will see that it will always be 1 because I have correctly initialize the variable of I into as 0. So it will always start with 0. If I add 1 to it, it will become 1. If I add 2, it will become 2. And I will not have that issue of random number showing up. And it's really important because now I'm just showing things here by printing a number to the screen. Imagine that if you are doing some sort of comparison and you're relying on the value of I to make some decisions, then the randomness of this value of I may or may not cause an issue when you are running the code for testing, but it might run into some issues next time you run the code. So be very careful about initialization, and always remember to initialize your variable when you declare that. All right, so the fourth common mistake that I want to show you here is something about the equality check that is performed in C++. So when do we want to do equality check? Typically, we want to do that if we have a conditional check. We want to have an if-else statement so that the program can branch off into different executions of code, and we will do that. So to do that, let's start with creating an integer. So let's say an integer I equals to 2. Right? So we initialize it with the number 2. As you might have learned that the equality check is represented in C++ as the equal sign, which is basically just one more equal sign than the assignment operator. So this is important as we describe this. So anyway, if we perform the equality check, we use an equal. But let's say I type, I'm trying to check if it is after I do some arithmetic operations, maybe the value of I will change, and I want to check if it is equal to 1. So let's say I forget to use the equal sign, and I accidentally type just one equal sign, right? And then, but in my mind, what I want is if it is equal to value is equal to 1, then I'm going to say I is now 1. Okay, and I'm going to add one more line over here and to make it look a little bit better. Now, so again, this code actually will compile. There's no syntactical error. So let's give it a run to see how it looks like. So as you can see that now I have the statement being printed, which is the I is now 1 being printed, whereas I actually want to set it to 2. I did not intend to change it into 1. So something is definitely wrong over here. Now, let's say I want to see what is the value of I. So let's say after the if statement, no matter it prints or not, I'll say I has a value of, so we'll see what I actually is containing. So I'm going to print the content of I over here, and let's run the code. So this happens after this if statement, no matter it prints or not. Okay, so let's compile and run, and you can see that I actually, the value is being changed into 1, and that's actually why we have this X is being printed. So what happens in C++ is if you do this thing, which is the assignment operator equal actually will return a value. And the return value is actually the value that is being assigned to the variable. So in this case, what we have is I is going to be set to 1, assigned to the value 1. So instead of 2, now it becomes 1. But the operator or the operations of assignment is going to return this result, which is 1 because it's set to 1. So that's why it goes into here. So this line actually does two things, or this expression actually does two things. One is it assigns the value or updates the value stored by I to 1, and at the same time return the result, which is setting the value of I into 1. Now, why do I? So what is the significance of that second result? So the second part is actually being used by the if statement. In C or C++, what really matters here is a number, is a numerical value. If it is 0, then C++ is going to treat it as false. If it is a non-zero, it is going to treat it as a non-zero, which is treated as true, no matter what the value is. So if I just change this to say 5, right? And let's run it again. You will see that it will still go into this because it's set to a non-zero value and it's being returned, and then it's being printed here because the condition is being considered as true. And of course, because of the first result, you will see I being updated into 5. Now, to show you one more thing, if I say it, set it to 0, now let's say I'm going to do this. So you will see that what happens is it only prints this line. So if I get rid of this line, let's comment it out, and then run again, you will see that this will not be called or executed. And the reason is that I is actually being set to 0. And 0, when it is being returned by the assignment operation, is considered as false in the if conditional change. So once again, uncomment this, and you'll see that I is indeed being set to 0. Right. And as I said, this will pass the compiler. The compiler will not complain anything to you. So it's very important for you to know that you are going to use this one. Now, let's say I'm going to change it into the correct way, which is the equality check. So, of course, this is going to perform a comparison. It will return either true or false. In this case, it's definitely false because I is not having the value 0. So this line is not being printed. But I will keep the original value because nothing has been changed. There's no new value content being assigned to the variable I. So that's why you see 2 over here that is not changed at all. So it's very important to be aware that what you're typing. In general, I would recommend students to always use two equal marks when you are performing when it is in a conditional. It's very unlikely to use one of these. It's possible there are some shortcuts or like kind of advanced coding. You will try to do 2 things in the same time. This is possible, but for learning how to program and as a beginner, I will always recommend that if you have a conditional check, you basically will never see something like that when you're writing the code. All right, so for the 5th common mistakes that I want to show you here is I think I'm saving the best for last. So what happens here is I'm going to show you a mistake that a lot of people make when they are doing comparison, especially when they're comparing non-integers. So let me show you the example first. So let's say this time I'm not using an integer, I'm using floats. So floats are basically numerical variables that can store decimal numbers. So I have one variable called, let's say, I, and I set it to 0.05, right? And another one that's called j, and we're going to call it, set it to 0.05 as well. Now I'm going to create another variable called k, and this k is simply just the sum of I and j. Right. Now, so at this point, we kind of expected that, you know what, k is going to be 0.1. So maybe I'll just do a check, right? So I'm going to say, do it in conditional if k equals, so don't forget about this double equal marks, and is equal to 0.1, right? Then I'm going to say something. I'm going to say, let's say I, and then plus j. So the 2 values stored by these variables is 0.1, because this is our conditional check, right? And just add a little bit of like spacing here, and we just do that. Right. So we have this, we check. If it is 0.1, which is what we expect, then it will print this line saying that 0.05 plus 0.05 equals to 0.1. Right, let's give it a run. You can see that nothing has shown. In fact, if you have an else statement here saying that it is not equal to 0.1, you will see that. And why is that the case? Because, I mean, we all know that I and j, these 2 values added together, has to be 0.1, but apparently it's not the case. So the reason behind this thing is actually comes from how computers stores numbers. So in computers, because they are using bits to store numbers, that is ones and zeros to store numbers, it has to internally convert or encode a numerical value from, say, in our case, a decimal system into a binary system. That means that they use a bunch of ones and zeros to represent a sequence of 2's being added together, or fractions of 2 added together. And in that conversion, some of the precision will be lost. So that's why when it is being converted back and being compared here, there will be some loss in precision over here. In fact, we can verify that is the case. So let's say I'm going to say print the value of k. So I will say k is actually something, right? So I'm going to print k. Now, if you simply just do it this way, by default, the program will only print up to a certain number of decimal places. So you will see that, wait, hold on a second, this is 0.1, why is it not equal to 0.1? So to further dig into the loss and precision, I am going to call another method or function called setPrecision. This allows us to print whatever is coming up with, say, more values or more places. So let's say I set it to 10 places. Right, I'm going to run it. Now, it will give me an error because this method or function is not defined automatically. So what we need to do is we are going to include a library called IOmanip, stand for IO manipulation. Right. Let's get a space over here to make it look more uniform. Okay, and let's run it again. So it is getting the library, it's doing some sort of linking while doing the compilation, and it's going to be printing a little bit more in precision. So you can see that, again, it's not being executed, this line. It's not being considered equals to 0.1. But then you can see that there's like a little 1.5 at the end, right? That's because of the representation of the decimal number in the binary representation and being encoded, the decoder back and forth. So that's why it is not entirely equal to 0.1. So let's say you really want to compare to 0.1, and you know that it's not precise at all. So how can you mitigate that? So typically, the way to do that is you are going to see if the value stored by k is not very different from the value that you want to compare to. So what it means is that the difference between k, the value of k, and 0.1 is so small that it's almost negligible. So in C, there's actually one value that you can use. So in order to do that, we need to include one more library. So it's called include, and it's called C float. So it's something that comes from the original, the older language C, so C float. In C float, there is a constant that is defined called FLT epsilon, which basically is the smallest value you can have between 1 and the value that is slightly larger than 1. So what we are going to do, I'm going to add it as a comment to show you how it actually explains. So essentially, we want to do something like this. Say very small value. So the difference is between a very small, it's basically a very small value. And because the difference can be positive or negative, we want to confine it between that range. So the same very small value, but it's a positive number. Right. So how do we convert that into a code? So we're going to replace this with something else. So whenever you see like between a range, what you do is that you are basically using two comparison expression. So you always have this and here, which stands for and in C++. So on the left hand side, you want to compare this part. So you want to do something like this. So what we can do is we can make use of this as this constant. FLT stands for float, and epsilon stands for very small value. And the difference, so what is the difference? The difference is going to be k minus 0.1. So we want to see how small the difference is going to be. Right. On the other hand, we are going to do the same thing, but this time we're going to compare this one with this guy. Right. So we are going to say, again, the difference is it can be positive or negative, and then it is going to be smaller than my very small value, which is again FLT epsilon EPSILON without the negative sign, because it itself is a positive number. Right. So with that comparison, we are going to run this code again. Now, as you can see, now we finally have this showing, because now it is not comparing the exact value, but it's comparing whether the difference is so small that they are almost equal, or they are technically the same value, right? So that's why you will see here. And again, k is actually this one when it is being converted from a binary representation within the computer back to a decimal representation, which is being shown onto the screen, right? In some cases, if you are comparing bigger values, there might be you might have to tweak this a little bit. But in most cases, if you are comparing a scalable, a typical value of decimal numbers or floats, this will be sufficient. So you are going to compare the difference between them. Now let's change it a little bit. Let's say I want to compare this to say 105, right? So they shouldn't be the same, because if you are looking at 3 decimal places of precision, they should not be the same. But let's just give it a try. So here, as you can see, it is no longer being considered as the difference is no longer being considered as small enough so that they are almost equal. Right? And then the actual value is like this, but then this is not being considered as equal to 0.1 anymore. So again, I should actually write it to this one. That makes a little bit more sense. So that's why it is important to know that when you are comparing float or even double, that is decimal numbers in a program, you should always consider comparing it with a difference instead of comparing the actual values, because there's a loss in precision going on over here. It's a very subtle issue. If you don't know about this, it's very easy to make that mistake. So that's why I save it as the last. So there you go. The 5 common mistakes students make when writing C++ programs. Here is a summary of that. So first of all, the placement of the increment and decrement operators matters. Where you put it, in front or behind of a variable. It will affect whether the increment or decrement is being executed before the value is being evaluated or not. The second one is the integer divided by an integer will give you an integer result. So no matter whether there is a remainder or not, it will always give you the integer part of the quotient, which essentially truncates whatever is in the decimal places. So be aware of that. The third one is always initialize a variable when you declare it, because if not, it might contain values that is random, and every time you run the program, it's going to be different. Some compilers automatically does that for you, but don't rely on that. As I have shown you in the example, at least this compiler does not automatically set it up for you. So you need to initialize your variable by yourself. So it's very important. The fourth one is to know that the difference between equality check and assignment, both of them are valid in C++, and they can both be in a conditional check, and they will mean very different things. And as I have shown you in the video, they will cause different outcome drastically. And last but not least, the comparison of floats or double numbers. Don't directly compare the values. Instead, compare the difference between them with the use of the float epsilon constant value or double epsilon constant value that is taken from the cfloat library. So that will allow you to have a more correct, logically correct comparison between float numbers and double numbers. All right. So honestly, I have made all these mistakes before, and I learned that in a hard way. So don't feel bad if you make those mistakes before. But hopefully this video explains why this is the case and helps you to remember not to make those mistakes again. If you enjoyed this video, please like and subscribe to my channel, and more will be coming. Thanks for watching. Bye.